So for those who like to sit around and watch these documentaries, BBC, this documentary is called Green Earth. And so it's one of these kind of shows a lot of different pictures and videos from around the world in high definition. It's actually about a 90-second clip focusing on wild oak. The reason I like to show it is it's one of these neat things with the biology of wild oak is that if you've ever worked in a weed science lab or just gotten bored, you know that we have these awns on the wild oak seed. And when those get wet and dry, they actually untwist and twist back up again. So what this documentary does is a really good job of showing kind of why the wild oats evolved that mechanism. It really helps them move around in the landscape and get to a suitable environment for enough seed to soil contact for germination. So for those with a lot of experience in wild oak, you might know that it's a big problem in conventional tillage, a large seed that can germinate from pretty deep. Well, in no-till environments or where it's evolved over in the Middle East, oftentimes we're not tilling. So as the seeds dry and wet, those awns kind of help the seed move around. And what we often talk about is that it will help them actually find a crack in the soil during that late summer time frame and corkscrew down into that crack. So even in no-till, we can have some major wild oak problems. And one of the reasons why is it's going to find all the seed soil contact it needs. This part of the video is really nice, kind of showing them falling into that crack. Get some rain, that crack seals up again, and it's ready to germinate the next year. So again, we'll kind of make that video available somehow later throughout the winter meeting season. Because again, David Attenborough does a much better job narrating this and likes the music behind that as well. So anytime, again, we get a highlight on weed, I like to show that. So, again, Brian Jenks probably had very similar data for those here yesterday, but what he does every year is collect samples that are suspected to be resistant. So these are data from Brian's research out in mine out in the greenhouse over the past couple of years, basically testing these different biotypes to resistance within our group 1 and our group 2 herbicides. I'm just showing basically from 2016 to 2020 timeframe, in each of the last 3 years, the percentage of samples he received that are indeed resistant to those herbicides. So I want to point out this is a targeted sampling process. Someone had an issue with the performance of program wild oat that year, sent the seed into him. So maybe a little bit artificially high compared to the average field. But in general, based on the group 1 and group 2 products, anywhere from 5 to 90% of samples sent into Brian do have resistance on an active ingredient to active ingredient basis. So we have found resistance to all the group 1 and group 2 products that we use, but it's not a complete loss for many. So just kind of want to point out some of this targeted research. Other reason I wanted to do that is and show that is Dr. Kirk Howard on campus, who does a lot of the teaching load for weed science, actually did conduct a random survey a couple of years ago. So Kirk and his team drove around the state. All these blue dots are different areas where they pulled off the side of the road and sampled wild oats. This wasn't targeted. This wasn't, we had a failure, we think we have resistance. This is just driving around and finding wild oats. And in general, what Kirk did is he circled basically on up and down I-29, about half the samples that he collected at random were resistant to group 1 and group 2 herbicides. Basically going that 94 corridor, about 1 out of 5 were resistant to group 1. So it's kind of showing maybe a more adequate or accurate picture of what the average field may look like across the state. If we want to really compare that snapshot in time, so that sample was conducted in 2022. So here is in the targeted sample on the right column, that's the results from Brian Jenks' greenhouse testing that year. So suspected resistance. This middle column that says random, about double the samples, almost 100 samples. That's the results that Dr. Howard found from those random samplings pulled across everything. So in general, we did still find resistance to every group 1 and group 2 herbicide just in this random sampling procedure, but often at a much lower frequency. So for instance, I pointed something like Puma or Varro, just on the sampling that year, pretty high detection level of resistance in the targeted process, but maybe 1 out of 5 or 1 out of 4, or whatever that math was, 2 out of 5, based on that random sampling. So just wanted to kind of get that picture of what we're seeing with resistance in wild oat. Shifting gears to water hemp, so I wanted to share some data, particularly from this past year on water hemp. Been working on this weed for a number of years now. We do have a resistance testing program. I hope most people have heard about it, but we run it through the National Ag Genotyping Center, a lab based on campus in Fargo. Every county office should have some packets, basically envelopes with some mailing packets in there, where if you suspect resistant water hemp or resistant kochia, you can take a couple of leaves off of a plant and send them to the lab. And so what that helps us do is get a better picture of where we have resistance. So this is water hemp, group 14 herbicides. That's our PPO inhibitors. Think about that in soybean, things like Flexstar, Reflex, Cobra, and Blazer. The gold counties are where we have found at least one population with group 14 resistance. And a lot of this map has been filled in with that sampling program. Just want to get that quick update there. I do want to show now some research from the past 2 years. This is, I think, important to work through because as we've been looking at soil residual herbicides again, as we lose some post-emergence herbicides in soybean for resistance or court decisions, just really kind of taking a much better look at what impact we can get out of these residual herbicides. Now, 2021 through 2023, every time we put out a trial, if you wanted to not rain in your geography, had me come and put out a trial those years. 2024, we put out the same set of trials we put out in 2023, but a much different scenario. And that's why I want to really discuss some of what we can expect out of residual herbicides. So the prior years to this last year, we often struggled to get a half-inch of rainfall from that first 2 weeks after application. And we often say that we want at least a half-inch of rainfall to get that herbicide into the soil and start killing weeds. 2023 for us was particularly dry at our research location. It took the first 4 weeks to get 1 inch of rainfall, and there's all small rainfall events along the way. 2024, after planting, we got 1 inch of rainfall 2 days later, and we got 6 inches of rain in the first 3 weeks. So a much wetter scenario, and for those particularly on the eastern part of the state, we were getting the question, is my residual herbicide even still there because of how much rain we got? So I just wanted to set up the stage there on different rainfall patterns on the 2 years of data I'll be showing. I want to show one particularly large trial that has 20 different treatments, but it makes sense how we kind of broke it down. So we have, I'm going to focus on this middle column and use trade names, but we're essentially looking at 1/4 pound and 1/2 pound of metribuzin. So old chemistry, but we're seeing a lot of value on things like water hemp and kochia. And in combination with different herbicides that we can use in soybean in this case. So a tank mix of Valor and Zidula, we essentially made our own Fierce, Surveil plus Zidula. If you use Fierce MTZ at 1.25 pints, that actually does not have a 1/4 pound of metribuzin. So that treatment is we spiked an additional metribuzin to get to that threshold we were looking at. And then we looked at 4 ounces of Spartan. And then what we could do when we started this trial was use a 1/2 pound of dicamba pre-emergence the past couple of years. So again, a large set of data, but essentially from top to bottom on this column, it's how we move from left to right across this chart. So we start MTZ1, that's a 1/4 pound of metribuzin. MTZ2 is a 1/2 pound. Then we have that Valor Zidula 1/4 pound, Valor Zidula 1/2 pound, so on and so forth until we have the individual herbicides without metribuzin on the far right. So I wanted to show this is 2023. Again, that year we did not get a 1/2 inch of rainfall within the first 2 weeks after planting. Data are from 6 weeks after planting. So by this point, I would have hoped you had a post-emergence application on because we didn't have complete control of anything, but what really wanted to test the residual power of these herbicides. So I drew a box around anything that was 84% or 81% or greater control. These were all statistically the same. What products tend to jump out? It's generally where we have 3 effective active ingredients on water hemp, or where we have at least 1 effective active ingredient with that high rate of metribuzin, something like 4 ounces of Spartan and a 1/2 pound of metribuzin. Where we had lower rates, where we had any of these products by themselves without the additional metribuzin, or if we just want to rely on metribuzin by itself, about 30 to 70% control based on the rate that we chose. So again, this is a low rainfall environment, what we probably deal with most years, to be honest. 2024, very high rainfall. Looks pretty similar for the most part. So again, where we have 2 or 3 effective active ingredients, I'm gonna bring my bar back up. Anything within this box was the best treatments, based on statistics from this past year. So again, 2 or 3 effective active ingredients, or we get something mixed in with that high rate of metribuzin. Where we saw some drop-offs were, again, some of these individual active ingredients. One thing I did want to point out, one of the products we use, Group 15 product, we use quite a bit in soybean and some other crops as well, is Vidua or pyroxasulfone. Dry year, we had about 15% control after 6 weeks, but we recognize this product performs better under higher moisture environments. Very good control of that particular product when we have the high rainfall environment. So there can be these year-to-year differences, and you can have a good experience when you use one effective active ingredient if you're in the right situation, like a high rainfall environment. When we start mixing these things together, you get 2 or 3 effective active ingredients. Dry year, wet year, still had very consistent control when we got to those right combinations. So that's the main takeaway I wanted there on when we have these different scenarios. 2024, we also had one trial where we just looked at the different Group 15 products by themselves. Do wish we had this in 2023, but we're probably just going to start doing this every year so we get the right environments. But since we want to show, again, this high rainfall environment, where we had 6 inches of rain within the first 3 weeks of planting, the Group 15 products that are the least water soluble, that's Zidua and Warrant in this case, were the best performers this year. Dual and Outlook, these 2 herbicides, more water or higher water solubility. So in a high rainfall environment, we realize that they're going to have some leaching involved, more chances for microbes to degrade them. So less control, but still after 6 weeks out of a single product, 50% control, I think you'd be living pretty good. So just showing what those Group 15s were doing in a high rainfall environment. Again, recommend having these tank mixed with something else for a more complete program. I want to dive a little bit into some data that we actually have. We have one individual trial across many areas of the state. And so this is a trial funded by the Soybean Council. We're looking at both crop safety and weed control, and I'll show data from both of those components. Because if we're talking more about using metribuzin, one of the first questions comes up, what about injury on the soybeans? So many people might remember some bad experiences, maybe in the 80s and 90s of injury on soybeans. And so we're like taking a little bit closer look at that. And then just the weed control that we can get. So not just focusing on pig weeds, which is where most of my trials tend to be, but capturing more weeds that we can look at. So in general, what we have is 4 base treatments where we have a 1/4 pound of metribuzin and a 1/2 pound of metribuzin. And then we're looking at 4 and 8 fluid ounces of Spartan. The kind we're thinking here is most people might be at this 1/4 pound of metribuzin and 4 ounces of Spartan. What happens if we double those rates? So we have combinations of all 3 of these. I'm going to be showing 8 different treatments on the next couple of slides. These are just the different locations that we looked at this in 2024. So kind of a busy slide here, but the next 3 will be laid out the same way. So I'm going to take a couple of seconds here. Control is there. From left to right, we have 1/4 pound of metribuzin. That's 1x. 1/2 pound is that 2x. 4 and 8 fluid ounces of Spartan is our 1 and 2x. Then we have combinations. So 1/4 pound of metribuzin with 8 ounces of Spartan. 1/2 pound of metribuzin with 4 ounces. 1/4 pound with 8. Sorry, this would be 1 and 1. That is a mistake on my part. And then on the right here is the 2x of each. What we had at both Hettinger in gold and Carrington in green, we did have kosher at 2 of our locations. And so for the most part, we had about 70 to 80% control when we had the 1 or 2x rate of metribuzin. Talked about what happened in Carrington there with sulfentrazone, but down in Hettinger, about that 80% control, and really took these higher combinations to get up to complete control. Again, at 6 weeks after planting, though, my hope is by 4 weeks, we're applying a herbicide to clean up any escapes. Carrington, we probably had some Group 14 resistance. Maybe a few other things that happened there, but sulfentrazone did not perform at that site this year, but metribuzin still performed quite well, and we did get a little bit of a benefit when having the tank mix there. We had kosher at 2 locations. Might be a bit of a surprise to some, but we also did get some data on 2 different foxtail species. So this is Minot, and yellow doesn't say the bar is yellow. That's yellow foxtail at Minot. Hettinger, we had green foxtail. So they're showing two different foxtail species at these two different locations. Same treatments there in order. In Minot's essentially 40 to 80% control just out of metribuzin on foxtail. So it brings us up because we often talk about metribuzin, sulfentrazone as broadleaf herbicides, and that's really the market that they fit. But we do get grass activity, and sometimes surprisingly good grass activity. So again, 40 to 80% control on yellow foxtail Minot, 75 to 80% on green down in Hettinger. Minot, we had a little bit lower control of sulfentrazone. I think most years when I apply sulfentrazone in the eastern part of the state, 10 to 30% control on grasses is what I typically see as well. So Brian, you're seeing the same thing in Minot on yellow foxtail. Down in Hettinger, a little bit better control on green foxtail, still about the 80%. And as we got into combinations, we kind of plateaued there at mid 80s to upper 90s based on the individual treatment. So we often are also talking about group 1, group 2 resistance in green foxtail. And so as we're looking at things like more metribuzin for kochia, we can also get some benefit out of that product for grass control as well. So we are repeating this again this next year. So everyone did have pretty adequate rainfall this year. No one saw the 6 to 8 inches that I saw at my research sites, but everyone had about 1 to 3 of the different sites within 2 weeks after planting. So crop safety, mentioned that was the next question. So not a whole lot happens with crop safety, so that's why I don't have any graph, just some text here. A little bit more detail, we did have 2 different soybean varieties. So if you work with your seed dealer, many of the seed companies will know their metribuzin tolerance and their tolerance to PPO inhibiting herbicides. So we had one variety that was tolerant to metribuzin, but sensitive to those group 14 herbicides. We had another soybean variety that was the complete opposite. Think that we might see maybe some metribuzin injury on one and no sulfentrazone injury or vice versa. But in this case, both varieties act the same. Across all these locations, and we did get about, we had a couple I didn't throw on the slide, so about 7 locations, 7 different unique soil types, never did see sulfentrazone injury. Metribuzin injury, we saw it twice. So at the high rate of metribuzin, that half pound active per acre, we did see at a site in Glendon, which is a sandy loam with a pH above 8, we did see some injury where we had 8 inches of rain that first 3 weeks after planting. So very challenging environment, but less than 10% metribuzin injury and no yield difference at the end of the year. Minot, again, we saw about 10% or less injury of metribuzin, which led to no yield differences at the end of the year. So some initial injury, but nothing, no differences in the combine when we took these plots to yield. The only time we saw any sort of yield difference was at our Fargo location. Just point out that is a clay soil with a high pH, or a pH of 8 at least. High rainfall environment, and with that clay, we had standing water throughout the first 6 weeks. So a very challenging environment, and we did have yield loss when we had the 8 ounces of Spartan and half pound of metribuzin. That's the only treatment that caused yield loss. So again, in the high rainfall year, crop safety seemed pretty good. This will all be repeated again next year. So I want to give plenty of confidence in this data set if we do want folks to start using some higher rates of those 2 products. So switching gears, someone will stop calling me and I can look at the time. Post-emergence control on water here. So what I did, a few new data points added to this. If you were here last year, you might remember this couple of slides here. Really wanted to take a look at specifically on water hemp. At least if we've conducted research over the past 6 years or so, we've had over 500 times where we've sprayed 3 to 4 inch tall water hemp with one of these 4 combinations. So either glufosinate by itself, 2,4-D in the form of Enlist 1 by itself, the tank mix of glufosinate and 2,4-D, or then we did have dicamba applications several times as well, Ingenio or Extendamax at the appropriate rates. Out of those 500 times we made these applications, about 300 where all we did was plant, wait for the weeds to get that tall, and then spray those products. The other 200 or so times, we had some sort of pre-emergence herbicide down, and then came back when the weeds were at 3 to 4 inches and made the application. What the data then looks like Glufosinate on the left, 2,4-D next to that. The tank mix is the second from right, and then the extended action ingredient treatments on the far right. So when we did nothing, no pre-emergence herbicide, you just sprayed those post-emergence at 3 to 4 inches. The number on top is the average control we saw out of all the observations. The tails on these box and whisker plots are the extremes that we saw. So for glufosinate, on average, we saw 80% control every time we did nothing except for spray glufosinate. That was our entire herbicide program. As low as 40%, a couple of times looks like we were living the rights and got 100% control. 2,4-D, a little bit less on average. The tank mix of glufosinate in list 1 has always looked quite good for us on the pig weeds and water hemp. And then dicamba was a little bit more variable for us at this site. Now, when we did anything pre-emergence, had a residual down, and came back when those weeds got to 3 to 4 inches, that's when we saw a lot better control. This is why, particularly in soybean, are one of the many reasons we really want the pre followed by post program. Now we're going from 80% on average to 90%. We've dropped out all those 40 to 80% observations. And basically, glufosinate always saw 85 to almost 100% control, on average 90. That tank mix of glufosinate in list 1, basically complete control every time we did that, following a residual. And then the 2 auxin herbicides by themselves, a little bit better and more consistent control. So again, as we head to this year, thinking about not just the value we're getting that residual herbicide from controlling weeds during that first 4 to 6 weeks, but also what that's adding to our post-emergence program and how we're getting better control out of those as well. So with just a couple minutes left, I was just going to give a brief update. Probably not enough time to get into the major details. So with glufosinate, 2 new products I wanted to point out this year, with one that will get a much bigger market share. This is straight out of the weed guide, the soybean section with glufosinate. The first one I'll point out is a product called Dalo. I don't know how available it's going to be, but if you hear that, it's a pre-mixture of glufosinate and then quizalofop or Sure 2. So basically an attempt here within 1 jug to get your broadleaf in your grass control. Has looked pretty good in the research trials that we have conducted. The Liberty Ultra is the one you've probably heard the most about. This is a resolved isomer of glufosinate. So the easiest way to describe it is because if you have ever worked with dual and know the whole iteration of dual into dual magnum, we had metolachlor. Now we always talk about S-metolachlor. So we're able to get the herbicidally active isomer concentrated into a formulation. Kind of the same thing with glufosinate here. With Liberty Ultra, the glufosinate P, or you also hear it called L-glufosinate, is the herbicidally active isomer, and it's a more concentrated version of that. It's kind of the main takeaway. If we're used to using 32 ounces of Liberty, we're recommending about 24 ounces of this Liberty Ultra. The last thing that unfortunately I don't have a whole lot of time to get into is there are some additional requirements with Liberty Ultra, but this is actually the first herbicide we got approved after the EPA implemented the herbicide strategy. So be happy to talk with anyone. I'll be here until lunch, but there are 2 new things on the label we're going to have to get used to hearing, and Liberty Ultra is just the first one we get to hear about this with. That's drift mitigation and runoff mitigation. So due to the fact that I'm about out of time, I would say if you plan on using the product, make sure you talk with either myself or your dealer about this. Relatively low bars to clear compared to what we were initially talking about a year ago. And again, as every herbicide gets registered or re-registered over the next 5 to 10 years, drift mitigation and runoff mitigation are this language we're going to get used to hearing. So that's Scott. I think I'm going to stop there and hopefully left time for a question. Otherwise, what I'm just going to do is jump ahead back to that QR code. So if those that want the electronic version, the weed guide on your phone, scan that code there.